Hello students, welcome back. Previously, we went through some limit problems on trigonometric functions. Oops. And then most of them required one of two, especially the first one. And then the first one, and both of them actually, were used to prove the derivative formulae for sine and cosine. That's sine, and that's for cosine, using the Newton quotient computation. That's left to only interested students, not everybody. Other trig functions, well, tangent is sine over cosine, so you can use the quotient rule and simplify. You're going to get sec squared. Secant is 1 over cosine, so again you can use the quotient rule to calculate and simplify. Quotient rule, quotient rule. You can deduce all those. But of course, the majority of the students, if not all students, will just go formula and then completely forget about the derivation. That's okay as far as I'm concerned. Now, if you take some further mathematics, in real analysis maybe, we'll prove all those, but here, let's not worry about those proofs. Let's think about how to utilize those. Okay, some derivatives of some functions that involve trigonometric functions. Let's see, we have some power functions and log functions and a trig function. Okay, all right, that looks good. Complicated, yeah, but that looks good to me. Let's see. Half of that, this may look like a quotient, but it's not really a quotient rule. It's 1/2 times this, so it's 1/2 times this, so it's not too bad. And this one here, 2, and then x cubed 1/2 power, and it's coming from denominator. So putting everything together, x to the negative 3/2 power. Oh, excuse me, 5/2 power. So you can rewrite like this. 1/2 is just coefficient, no worry there. And then first function, second function. All right, let's go ahead with the derivative computation. Derivative of the first function times the second function. First function times the derivative of the second function. That's the structure of the product rule. All right. Now let's go ahead, calculate the derivative of the first function. Go ahead, what do you get? Start the playback and try. What do you get? 6x plus -2 times -5/2, so positive 5 x to the, subtracting 1 from the power, -7/2. That's what I'm getting. And then now the derivative of the second function, what do you have? 3 times the derivative of log function, 1 over x, or x to the negative first power. I prefer to have the x to the negative first power, but if you want 1 over x, that's fine. And the derivative of tangent. Well, that completes the problem. Oh, here I considered this denominator 2 at the same time. So I have 2 here and then 2 there. Yeah, this is correct and this is simpler by taking this 1/2 out. So product rule associated to power function, logarithmic function, and a trig function. Next, how about some quotient rule? Previously, we did a product rule example, so let's consider a quotient rule example this time. So the derivative is denominator squared. That's so conspicuous that not many people miss it. And then we have u primed and then v and then u times v prime. Alright? So parenthesis is just copy and pasting, nothing to think about. Bracket requires a derivative computation. Needs something. So derivative of the numerator here, the derivative of x squared is 2x. Derivative of sine is cosine. Alright, how about the derivative of denominator? Derivative of tangent is secant squared. And that completes the problem. What do you have here? Yeah, the same thing. So u prime v minus uv prime, and then u prime, you do your computation. V prime, again, you do the computation. Enough time for one more. More? Nope, we're going to consider those later after chain rule. Today, let's stick to this one. Okay, alright, that looks like a challenge. Okay, we need denominator squared. And then we need u prime, derivative of numerator, and the denominator. Well, that doesn't require a lot of work, just copying and pasting. And then the numerator, and then the derivative of the denominator. Okay, that's the structure. The parenthesis part is just copy and pasting. It doesn't require anything. The derivative computation goes to this bracket, numerator, and that bracket, denominator. Ready? Derivative of 3y squared, that's 6y. The derivative of tangent, what is the derivative of tangent? Secant squared. So that completes the derivative of the numerator. Now, let's go to, oh, okay, that's gonna be a bit bigger challenge. The derivative of sine is cosine. And then the derivative of y squared cosine of y, oh my goodness, that's another product rule. Well, okay, alright. If you can't, just go ahead and do that right away. Let's calculate this. Derivative of first function times second function plus first function times the derivative of the second function. So this is derivative of first function, 2y, and this one here is the derivative of second function, negative sine of y. See that? That has to go here. So that's 2y cosine of y plus y squared, negative sine of y. So let me put negative here and oh, okay. Let me try to rewrite it here. font was too big. Okay, alright. Let's keep it about this. So u prime v, that's just copying. And then u v prime, that's just copying, and v squared. U prime, that was easy, derivative of the numerator. V prime, that required some work. Sine becoming cosine, that was easy. But here, which I'm highlighting in red right here, required a product rule as is d down here. So 2y cosine of y and the y squared times negative sine of y. So we get this negative y squared sine of y there. We may have to use this product rule and quotient rule multiple times. With trigonometric functions, good luck. Oh wait, we do have some time, so maybe some more derivatives here. Let's see. No, they are chain rule. That two is chain rule, that two is chain rule. We are not ready for these yet. Okay, alright, let's stop here. And then let's come back and discuss a tangency problem in a separate video.